Alright, try to make this video as quick as possible. This is just a homework review. This is Castle Learning. What's today's date? It is November 18th, so this is the friction review stuff. Need a calculator, reference table. Let's get into it. So, I don't know what order you had them in, but the vector diagram represents a box sliding. So it's sliding downhill. Which way is friction going? Well, friction always goes opposite the motion. So it's going towards choice 4, D. Alright, the next one. As represented in the diagram below, a constant 15 Newton force, F, there we go, is applied to a 2.5 kilogram box, accelerating the box at 2 meters per second squared. Okay, so A equals 2.5 meters per second squared. Sweet. If this is small, go full screen. Alright, what's the question? Determine the magnitude of the friction force on the box. Alright. They don't tell us the surface is. So what we need to do is we got to figure out our net force. This is equal to MA. Because our net force is also equal to our total forces. So we have F, which we see right here, but we also know there's some force of friction going against it. So it's F plus your force of friction equals the net force. So we can find F net first by doing our mass, which is 2.5 kilograms, multiplied by our acceleration, which is this y. Oh, I'm sorry, this is 2.0. That was a mistake. I was going to say they use the same number. And so we are 2.0 meters per second squared. So F net equals 5 newtons. So then if our net force is 5 newtons, but F is 15 newtons, how much is our friction force? Friction force must be negative 10 newtons. And the magnitude, so they're just looking for 10 newtons here. Question 3. I'm going to get the cursor out of there. Calculate the magnitude of the force of friction acting on the moving block. Okay, so we need friction force again. What do we got? We got copper, steel table, 4 newtons. Mass of that. Alright. Do we need to do anything? The diagram below represents sliding to the right on a horizontal table. Okay. Alright, so calculate the friction force. Friction force equals mu times the normal force. So I don't think we actually need this 4 newtons. That seems to be a dummy. So we got to figure out your normal force, and to do that we just we know Fg equals mg, and we know Fg goes here, and we know Fn is going to equal negative Fg. So we'll do this first. So we got 0.2 kilograms times negative 9.81 meters per second squared. So here we go. We get 0.2 times negative 9.81. Oops, 0.2 times negative 9.81. You get what? Negative 1.962 newtons. So that's our normal force. So we sub that in. 1.962 newtons. Now we need the coefficient. So we have copper sliding on steel. So we look here, we got copper and steel. And we want to use the kinetic value, which is going to be 0.36. So we put 0.36 here. And then we multiply to get our friction force. So 0.36 times 1.962. Our force of friction is equal to 0.71 newtons. On to the next one. An 8 Newton wooden block slides across a horizontal wooden floor at constant velocity. Calculate the magnitude of the kinetic friction force. All right, friction force equals mu times normal. This one's a little bit easier. We're finding our friction force. We need to get mu. So we have wooden block sliding on wood. So back to the table. Wood on wood. Sliding means kinetic. We want 0.3. So 0.30 times our normal force, which is 8 newtons. We don't need to times by 9.81 because it gave us the weight in newtons already. They did not get a mass. So 0.3 times 8, we get 2.4, choice 1. All right, next one, 0.5 kilogram puck sliding on a shuffleboard court is slow to rest by friction force of 1.2. What is the coefficient? Same equation, mu times the normal force. However, this time we know the friction force. We're looking for mu, and we don't know this. So to make this a normal force, we times it by 9.81. So 0.5 times 9.81, you get 4.905 newtons. So substitute that in. 1.2 divided by 4.905, 1.2 divided by 4.905. We get 0.24. So the answer again is choice 1. Nice. Question 6. As shown in the diagram below, an open box and its contents, an open box, why? I don't know, has a mass of 5 kilograms. A horizontal force of 15 newtons is required to push it at constant speed. 1.5 meters. Okay, good. So constant speed means F net equals 0 newtons, which means our friction force is also equal to 15 newtons because it cancels that force out. So the inertia of the box and its contents increases. Throwback, inertia is just mass. So the mass of the box and its contents increases if there's an increase in the speed? Nope. The mass? Yes. The magnitude of the horizontal force? Nope. The coefficient. Inertia is mass. That's it. So that's choice 2. Question 7. An ice skater applies a horizontal force of a horizontal force to a 20 kilogram block on a frictionless, love it, level ice, causing the block to accelerate uniformly at 1.4 meters per second squared to the right. After the skater stops pushing the block, it slides onto a region of ice that's covered with a layer of sand, aka friction. The coefficient of friction is 0.28. Calculate the magnitude of the friction force acting. I would love to. Friction force equals mu times the normal force. Okay, so substitute in friction force equals, they gave us the mu, 0.28. I need the normal force, so 20 kilograms to get the normal force, times it by 9.81, because it's equal to the gravitational force, so 20 times 9.81. So this is 196.2 newtons. Then we just have to multiply this by the normal force, which is 196.2 newtons. Again, force gravity going down, normal force going up, they're equal to each other. That's why I'm multiplying this mass times gravity. So let's do this now. 0.28 times 196.2. Friction force is, we'll just round it. Oh, that's bad, 55 newtons. All right. Question 8. Which statement best explains why wet sand used to cut through fine optical crystal is constantly lubricated with oil? We want less friction. So it's decreasing the friction. It's choice 1. So we didn't mention this stuff yet, so if you said 1 or 2, that's not bad. Internal energy is just another name of friction. So you want to decrease friction, obviously, which minimizes an increase. Minimizing an increase, yeah. We want the least amount. Okay. It's possible, rather. Oh, this is a big question. Oh, 9. So many parts. What am I, a monster? Base your answers to the question on the information below. A horizontal force of 8 newtons is used to pull a 20 newton wooden box towards the right along a wood surface. Wood on wood again. Okay. On the diagram below, shows the vector representing the normal force. Calculate. Are these in order? Yeah, all right, calculate the magnitude of the friction. I probably thought this was a multiple choice question when I picked it. Calculate the magnitude of the frictional force acting. Okay. All right, I was just looking. I don't know if it says. Oh, okay, no, okay, there's more to it. All right, so friction force, here we go, is equal to mu times the normal force. I thought it could just cancel out, but it doesn't say where it got a constant velocity. So wood on wood, are we moving? Yep. All right. So wood on wood, kinetic is 0.3. So 0.30 times our normal force, which is just 20 newtons. We don't have to solve. It gave it to us in newtons. So calculator 0.3 times 20 is 6. So the answer here is 6.0 newtons. Calculate the net force. Well, I've got 8 going to the right. I get 6 newtons going to the left. So 8 minus 6, my net force is 2.0 newtons. Determine the mass of the block. Fg equals mg. Oh, we're doing it backwards. So your weight is equal to 20 newtons, which is equal to your mass times negative 9.81. Really, this should be a negative there too, meters per second squared. So negative 20 divided by negative 9.81. Your mass is 2.04 kilograms. And calculate your acceleration. F net equals ma. F net is 2. Mass is 2.04. A, 2 divided by 2.04 is 0.98 meters per second squared. Guess what? Newtons, meters per second squared. No, kilograms. What am I doing? kgs. All right, question 10. A book sliding across a horizontal tabletop slows until it comes to rest. Describe what change, if any, occurs to the book's kinetic energy and internal energy. Oh, we didn't learn about this. Skip it. But if you want to know, your kinetic energy decreases and your internal increases. Sorry. A skier on wax skis is pulled at a constant speed. All right. F net equals 0 newtons. Love it. Across level snow by a horizontal force of 39 newtons. Calculate the normal force. All right. So here we go. So F friction equals mu times this. So my friction force is 39 newtons, because that's canceling out with what they're pulling. Mu, wax skis on snow. Oddly specific, go to the reference table. Wax skis on snow, 0.05. 0.05 times your normal force. Do a little division. I'm using kinetic because it says a constant speed. So we do 39 divided by 0.05. I get 780 newtons. So 780 newtons. Good. Compared to the force needed to start a sliding crate across a rough floor, the force needed to keep it sliding is going to be less, because kinetic is always less than static. All right, 3 left, home stretch. The coefficient of kinetic friction between a 780 Newton crate and a warehouse floor is 0.2. Calculate the horizontal force required to move it at constant speed. So really what we're saying here, like before, you have a force this way, you have a friction force going the other way, but because it has a constant speed, F net equals 0 because A equals 0. So these two forces must equal each other. Uh-oh, I got a boogie. So force of friction is what we're looking for, so we just do 0.200 times 780 newtons. That was the answer to the last one. Funny. So 0.2 times 780, we get 156 newtons. If the box at rest, the net force acting on it is 0. Love this question. It looks so tricky, but if it's at rest, just like here, F net equals 0. Last question, diagram a granite block slid, so we have kinetic by force. All right, which pair of quantities could be used to determine the coefficient? Okay, well, let's think about it. What's the only equation that has coefficient in it? This one. So let's see, something with the force of friction and something with the normal force. So is there anything that has the force of friction and the normal force? Boom. Perfect. All right, there you go. All right, so that's all the questions. That was probably a long video. We got 15 minutes. Jeez. So I'm going to sign off. Hopefully this helps with your homework. Bye.